let's see on kinetics. So here basically we are going to see how fast a reaction will happen, whether a reaction is happening or not. If the reaction happens, how far the reaction will proceed. So that is what mainly measured in chemical kinetics. Now in the chemical kinetics, very important part is you should know the concentration time curve. Now when you take a reaction, a reactant becomes a product, and then we can plot the concentration time graph for both the reactant and product separately. So always with time the reaction is being consumed, therefore a fixed amount of reactant will decrease with time. With time the reactant amount will get decreased, but the product initially it is 0, but its concentration increase with time, and then once the reactant is over, the product concentration will become constant. So this is the concentration time curve for product and the reactants. Okay, now when you take the gradient of this graph, gradient of this graph is actually equal to the rate of the reaction. Now rate of reaction is measured as change in concentration over change in time. So the gradient of this graph is going to give you the rate of the reaction. Always rate is change in concentration with time. Always the concentration of the reactants will decrease with time, and concentration of the products will increase with time. So that's the basics actually. Then there are three types of reactions. Okay, we can identify three types of reactions. That is very fast reactions. You will have some reactions occurring very fast, and you have very slow reactions as well, and you also have moderate reactions. So these are the different types of reactions we can observe in our day-to-day life. So the main part of this lesson, what we are going to learn is the rate law. So when you take the rate law is showing the relationship between the rate and the concentration. Okay, now sometimes when you increase the concentration of the reactants, the rate might double, or the rate can be 4 times. Or else now sometimes the reactant will not have any effect on the rate. That means how much ever you increase the concentration of the reactant, the rate will not increase. So in what do we study in rate law is the relationship of rate with concentration. Okay, how rate is having an effect on the concentration of the reactant or product. Okay, so now when you take the rate law, so what does the rate law shows is that when you take the rate, okay, that is directly proportional to the concentration term of that reactant, which is written to a certain power. That means rate of a reaction is proportional to the concentration of the reactant to the power x. Now this x is actually known as the order of the reaction. Okay, there are different orders of reaction: first order, second order, third order. We will be learning after this. Now x is the order with respect to the reactant, not the reaction. There is a order for the reaction as well. Here x is simply meaning the order with respect to the reactant. Okay, order with respect to the reactant. So this is what the rate law means. That means rate of a reaction is proportional to the concentration of the reactant to the power of its order. Okay, now this order, this x can be 0, 1, 2, likewise the order of the reaction can change. Okay, but anyway 2 is the maximum. Okay, usually the order with respect to reactant will be like maximum 2. Okay, now we are going to see different orders of reactions. Okay, now let's see what is this 0th order. Now you will have now when the order is 0, we will call it as the 0th order. When it is 1, it's the first order. When it is 2, it is the second order. Okay, now this rate is proportional to the reactant. That means when you convert this proportion to a equal sign, what happens is you are getting a constant. That constant is the k, and we call this as the rate constant. And then you will have the concentration of the reactants and its power. Power is the order with respect to the reactant. Okay, so this is the introduction. Now first let's see how we are going to apply rate laws. Under the rate law, first we are going to study about the zero order rate law. Okay, now if the order with respect to a reactant, okay, order with respect to a reactant is 0, then this is actually a zeroth order rate law. Now we know the rate law. Rate is proportional to the concentration of the reactant to the power x. Now x is equal to 0. That means rate is equal to k, which is the rate constant, a to the power 0. Okay, which is equal to a to the power 0. Now we know that a to the power 0 is 1. Therefore rate is equal to rate constant. So in a zeroth order reaction, okay, rate is always equal to the rate constant. That means you can understand that reactant has no effect on the rate of the reaction. Whatever the concentration you increase or decrease, rate will not change. If you increase or decrease the concentration of the reactant, the rate will not change, because rate is equal to rate constant in the zeroth order reaction, and the constants are not changing. No? Therefore, in a zeroth order reaction, rate does not depend on the concentration of the reactant. So when we are doing sums, it will be more clear. Second one is the first order rate law. So there the order with respect to reactant will be 1. Okay. Here now x will be equal to what? 1. Then when x is equal to 1, we can now modify the rate law. Now rate law is equal to k concentration of the reactant to the power x. Now rate is equal to k a to the power 1. A to the power 1 is 1. Okay. So this is the rate. Now you can see the rate depends on the concentration of A. So when A changes, rate will change. Okay. I hope it's clear. Now I forgot to mention one thing, the unit. Now here you can see rate is equal to K. No? Rate is equal to mole per decimeter cube per second, because rate is equal to change in concentration over time. So that is concentration over time. No? So mole per decimeter cube per second is the unit of rate. Therefore the unit of K will be what? Mole per decimeter cube per second for a first order reaction. Okay, for a first order reaction, unit of K is mole per decimeter cube per second. But this unit of K is very special. It is changing from different order of the rate law. The unit of the K will change. So in a first order reaction, unit of the K is mole per decimeter cube per second. Now sometimes with the unit of the K itself, you can find out the order of a reactant. Okay, so that's a very important question point. Now here look at this. Now here rate is equal to K into A. That means K is equal to what? Rate over concentration of A, right? Now the unit of R, rate is mole per decimeter cube per second. Unit of A is mole per decimeter cube. Now mole per decimeter cube cancels, and the unit of K is per second. So in a first order reaction, okay, first order reaction, unit of K is per second. First order reaction, unit of K is per second. So when you have K in, whenever K is given with per second, then you should understand this is the first order rate law. But if K has mole per decimeter cube per second, that is zeroth order reaction. Okay, so those are important points. So first order reaction, this is the rate law. Okay. Now we will come on the second order rate law. Second order rate law. So when you take the second order rate law, okay, R equal K a to the power x. No, x is equal to 2. Order with respect to the reaction is 2. Then R equals K concentration of A squared. Now again the unit of K will change. K is equal to rate over A squared. Rate is what? Mole per decimeter cube per second. What is A? A is the concentration, no? Mole per decimeter cube squared. Okay. Now one of this will get cut and 1 mole per decimeter cube remain in the denominator. So you take it on top. Mole minus 1 decimeter cube per second. So this is the unit of K for a second order reaction. So you can see that from zeroth order reaction, first order, second order, the unit of the K is changing. From the unit of the K, you can definitely find the order with respect to a reactor. Okay. So that's it with the different rate orders. Now we have to see how we can actually apply this in the questions and why are we using this. So that is the main thing. And also one important point to highlight on the rate constant. Now rate constant definitely depend on the temperature. Okay, when temperature changes, the rate constant will change, and it will also depend on the reaction pathway. Now the reactions can happen in different mechanisms. No, if the reaction pathway changes, the rate constant will change. Other than that, it will be constant. Okay. Okay, now let's just see an example how to apply what we learned now. Look at this. Now let's say there's a reaction A plus B becoming C or something. In the example they have given that order with respect to A is 2. Order with respect to B is 1. Initial rate. Initial rate is capital R. Okay. Initial rate is capital R. And these are the initial concentrations. A and B is the initial concentration. Now what are they doing is double the A and B. Now they have doubled the concentration of A and B, and they are saying you to find the new rate. Okay, find the new rate. Now what's the rate law? Now you should write the rate law first. R equals to K. Always the rate law is depending on the concentration of the reactants. Now earlier whatever the example I did is just one reactant. Okay, but you can have more than one reactant. So when you have more than one reactant, you have to just put the multiples of it. Okay, K times the concentration of A to the power 2, because they have given the rate order 2. Then multiply by the concentration of B. Okay, B to the power 1. So this is the rate law for this reaction. Okay, always rate depend on the rate constant and the multiplication of the concentration of the reactants. So the concentration of the reaction you should raise to the power of the order of the reaction. Okay, now we have raised it. Now this is the initial rate. Now you have to find the new rate because the concentration of A and B has changed. Now if the AB concentration changes, obviously rate will change. Now we'll write the new expression K, but now the concentration of A is 2A because it is doubled, 2A to the power 2. Concentration of B is 2B because it is doubled than the initial. Okay, this is equation number 2. Now you can divide 1 by 2, therefore you can find the new rate in terms of the old one. Okay, so R over R dash is equal to K A squared into B over K. Now this is 2A squared, no? That means 4A squared and into 2B. k cancels, a squared cancels, b cancels, r over r dash is equal to 1 over 8 here, 4 times 2. Then 8r is equal to r dash. Now you can see that initially the rate was r, but when you double all the reactants concentration, it has become 8r. Now the new rate is 8 times than the initial one. So that's how we find the new rate, effect of rate due to the concentration of the reactants. Okay, so and this is how we write the rate expression, rate law. So it will change. Okay, anyway what you should do is k times the concentration of the reactants. So this concentration can be 1, there can be 1 reactant, 2 reactant, okay, and the orders will differ. Okay, it depends. Now there can be some questions like telling you to find the order as well. Okay, you will have to find the order. Okay. Okay, let's see one of that now. Now look at this. Now they say when concentration of A is doubled, rate becomes 8 times. Okay, rate is becoming 8 times the initial when you double the concentration of A. Now when you double the concentration of B, here also you have A and B as reactants. So when you double the concentration of B, rate become 2 times. So rate is big. Now if it is R means it will become 2R. Okay. And when concentration of C is doubled, that means there are 3 reactants in this reaction. Okay. Rate becomes 4 times. Okay, rate is becoming 4 times. Now we can work it out for each reactant and find out the, now let's say the order of this reaction is A, B and C. We don't know the order of the reactions. Okay. Now first step is you have to find A, B, C, the order of the reaction. Okay. Then you have to write the rate law, and then you have to find the concept called total order. Total order means addition of the order of the reactants. Okay. Now let's apply for A. Now when you are finding for A, other reactants concentration will be constant. Okay. Now let's take all initial rate as R. Okay. Initial rate R equal to K A to the power simple A. This is the rate law now for the initial one. Now the new rate has become what? 8 times the initial when you double the concentration of A. When you double the concentration of A, rate became 8 times. Now in this time, you might wonder where is B and C, right? B to the power B and C to the power C. B to the power B and C to the power C. Now if you want to find the order of one of the reactant, all the reactants should remain in the same concentration. Otherwise you can't find it. Okay. Now this is the first situation and second situation. So when you consider both these situations, B and C concentrations will be the same. Then when you divide, what happens? These get cancelled, no? Then easily you can find the rate order of the A. So this is how essay questions also come. They will give a set of data for you. Okay, so if you want to find the rate order of A, you have to choose two situations where the other reactants concentrations are same. Then they will get cancelled and you can easily find it. Okay, they will be the same. Okay, that's how when we do essay questions you will easily understand that. Now you divide 2 by 1 or something. When you divide 2 by 1, 8r over r is equal, now these get cancelled, k 2a to the power a over k a to the power a, k cancels, 8. Now 8 is equal to 2a over a whole thing to the power a. Now this a and a cancels. Now 8 equals 2 to the power a. Then a has to be 3, right? Because 2 to the power 3 is only 8. Therefore, now we have found out simple a is 3. Okay, simple a is 3. Now same way you can apply for B now. When you apply for B, concentration of A and C will remain the same. Okay, only the B concentration will change. Now B they have doubled it. R equal to K B to the power simple B. Now it has become 2 times. Okay, concentration becomes 2 times when you double the concentration of B, 2B to the power B. Now A and C will remain the same. Okay, so it will get cancelled in both the equations. Now you divide this, right? R 1 over 2 is equal to B cancels, half to the power simple B. Half, now B has to be 1, right? Then only half to the power 1 half. Now B is 1. We found B. Now you want to find C. If you want to find C, concentration of A and B has to be the same. So R equals K C to the power C. Now when you double the concentration of C, rate becomes 4 times. So it becomes 4R K concentration of C to the power C, 2C to the power C. Okay. Now you divide R K C C. 1 over 4 is equal to half to the power simple C. Now C has to be 2, right? Then only you can get 1 over 4. So A is 3, B is 1 and C is 2. Now you can write the rate law. What's the rate law? R equals to K concentration of A to the power simple A. Simple A is 3. Concentration of B to the power simple B. B is 1. So you don't need to write 1. Concentration of C to the power 2. This is the rate law of this reaction. So how do we write rate law? Rate equals to K times the multiple of all the concentration of all the reactants where they are raised to the power of the order with respect to that reaction. Order with respect to A is 3, with respect to B is 1 and with respect to C is 2, and this is the rate law for this reaction. Sometimes in structures they just tell you to write the rate law. You will have around 10 marks for that. So writing rate law is not at all difficult. Okay, essay questions you will have to find the order like this and then write the rate law. So this is the basic of this lesson. Most of the essay questions are like this. You will have a set of data. Now here we are just working with unknown terms. No, you will have to work with real values as well. You will find rate, you will find K. Okay, so that's the basics. After that we have like mechanisms of the reactions, single step, multi-step. Now some reactions, the stoichiometry of the reactants itself will be equal to the rate order. Okay, so there are some reactions like that as well. Anyway, this is the most frequently questioned one, is this pattern. Okay, where you have to find the rate laws and then find the rate, then you write the rate law. Now look at this Roman number 3. Roman number 3 is asking the total order of the reaction. Total order means you have to add the rate orders of individual reactants. Rate order of A is 3, B is 1, C is 2. Then 3 plus 2, 5, 5 plus 1, 6. It's the total order. Those are the common, this is the most common question asked. And after that there is a part with half-life. Okay, so that's frequently coming in the MCQs. Half-life, it comes in the essays as well, but that's like for the first order, second order, third order, you have a equation to find half-life, and then you can apply. So this is a basic theory, but the question comes in different ways. In creative, innovative ways, the question comes. Sometimes they won't give the order of the reactant, but they will have give the unit of the K. So with unit of K, now you can find the, here see, zeroth order reaction, K has mole per decimeter cube per second. First order, the unit of K is per second. Second order, it is mole minus 1 decimeter cube S minus 1. Okay. So that way, so when we do more questions, you will get adapted to this. So this is the most common variety. So from next class, we will include questions on chemical kinetics as well. Okay, so you can do past papers and revise the lesson and key.